last lecture, seen that what is the atomorphism on a field. Okay, what is the atomorphism on a field? With same domain and codomain, the mapping is isomorphism. Okay, and also we seen that on the set of rational number, we define only one atomorphism. That is,
सर तुमचा व्हॉइस खूप लो येते.
okay, wait a minute. On the field of rational number, we define only one atomorphism, which is identity mapping. Okay, phi of x is equal to x. And also the set of real number. On the set of real number, we define also only one atomorphism, which is identity mapping. Okay, but on the set of complex number, we define two atomorphisms. That is phi 1 of a plus ib is equal to a plus ib, which is identity mapping, and phi 2 is equal to a plus ib is equal to a minus ib. Okay. Now we start the third unit, Galois theory. Okay, unit number third, Galois theory. Okay, now the first point for the first point is the elements of Galois theory. Elements of Galois theory. Okay, look at it. Now, if p of x, okay, let p of x be the polynomial. Let p of x be a polynomial in capital F of x. Be a polynomial in capital F of x, where f is any field, where capital F is any field. Okay, so in this section, we shall associate with p of x a group. Okay, so in this section, we shall associate with p of x a group, a group called Galois group of p of x, called the Galois group of p of x. Thus, the Galois group will turn out to be the Galois group will turn out to be a certain permutation. Okay, what is the permutation? 1 1 onto functions from one set to that set itself. Okay, finite set. Okay, the certain permutation group of the roots of the polynomial, Okay, and in this section, we assume that all the fields are of the characteristic 0. In this section, we assume that all the fields are the characteristic 0. Okay, and the next point is atomorphism of a field. Next point is atomorphism. Atomorphism of a field. Atomorphism of a field. What is atomorphism? A one-one. Okay. One-one mapping. A one-one mapping. Suppose that mapping is sigma of a field K. Of a field capital K onto itself. That means that function must be onto and one also. Okay. K onto itself. Itself means that codomain must be the field K. Okay. It's called an automorphism. An automorphism of K. If which two condition? First one, sigma of A plus B is equal to what? Sigma of A plus sigma of B. And second one is sigma of A into B is equal to sigma of A into sigma of B. For all A and B belongs to capital K. Okay, so this is the definition of atomorphism of a field. A one-one mapping sigma of the field K onto itself. It's called atomorphism of K if sigma of A plus B is equal to sigma A plus sigma B, and sigma A into B is equal to sigma A into sigma B for all AB belongs to K. Okay, any doubt up to here?
No, sir.
Now, the two automorphisms sigma 1 and sigma 2 are said to be equal if sigma 1 of A is equal to sigma 2 of A for all A belongs to K. Okay. When we are going to say that the two automorphism are equals, the two automorphism, the two automorphism. Suppose that sigma 1 and sigma 2 are said to be equal, are said to be equal if sigma 1 of A is equal to sigma 2 of A for all A belongs to capital K. Okay, for each and every element of K, if sigma 1 is equal to sigma 2 of A, then the two atomorphisms are said to be equal. Okay, now some notes are there on atomorphism. Write down that notes. What are the notes? First one, if sigma is an atomorphism on the field K, then sigma of 0 is equal to 0, sigma of 1 is equal to 1, sigma of minus A is equal to minus sigma of A. Okay, what are the notes? If sigma is an atomorphism, it's an atomorphism of a field K, of a field capital K, then first one, identity maps to identity. Okay, additive identity. Second one, sigma of minus A is equal to minus sigma of A. As a proof पण आहे, पण here we don't need to prove that all these things. Okay. Third one, sigma of one identity, multiplicative identity maps to multiplicative identity. Why? Because sigma is an isomorphism, atomorphism. Okay. Fourth, sigma of minus 1 is equal to minus 1. And fifth one, if A is not equal to 0, then sigma of A inverse is equal to sigma of A bracket inverse. Okay, these are the final. Any doubt up to here? ह्याचं प्रूफ आहे. जर प्रूफ हवा असेल तर कुठल्याही टेक्स्टबुक रेफर करा, तुम्हाला मिळून जाते. ओके, एनी डाऊट अप टू हिअर?
No, sir.
Okay, now the next theorem. Look at it here. The set of all atomorphism, the collection of all the atomorphism on the field K, then A of K is equal to the group with respect to composition of two functions. What is the theorem? Statement. Let A of K is what? Be the collection of, be the collection of all automorphisms, automorphism, the set of collection of all the atomorphism of a field K. Okay, म्हणजे each and every element in this set is the what? Automorphism on K. म्हणजे यातला एलिमेंट कसा असेल तुमचा? फंक्शन असेल. ओके, in the set A of K, the nature of element is a function. Okay, so let A of A be the collection of all the atomorphism of a field K, then prove that, A of K, okay, this non-empty set is a group, with respect to, what is the algebraic composition? Composition of two functions. What is the operation? Composition of two functions. Okay, that means the set A of K into this composition, this algebraic structure forms a group. Okay, now proof. Any doubt in the statement?
No, sir.
Okay, now let A of K be the collection of all the atomorphism. Write down all the given things. Be the collection of all automorphism of a field K. Okay, that is, we can write that set A of K is equal to F, such that F is an automorphism. Okay, is it correct? A of K
Yes,
is
sir.
equal to F, such that F is an automorphism of K. Capital K. Okay, now we have to prove that this set with operation composition of two functions forms a group. Okay, now to prove that A of K is a group, with respect to composite mapping, as the operation. Okay. Now, what is the first property to prove the group? Is closure property. Okay, first write down the closure property, not closed. Okay, closure property. How we are going to prove this one? Let F and G are the two elements from हा सेट नॉन एम्प्टी आहे का? कसं प्रूव्ह करणार? Whether this set is non-empty? Yes, it is non-empty. Why? Because
Yes, sir.
at least one mapping is there.
Identity.
That is identity mapping. Okay. एक तरी मॅपिंग आहे ह्याच्यात. Identity mapping. Identity mapping must be an what? Atomorphism. 1, 1, onto an isomorphism. So here we can take elements from this set. Okay, let F and G are two elements belongs to the set A of K. Then F and G is are what? 1, 1 mappings. F and G are what? 1, 1 mappings of K onto itself. K onto itself. Okay. Now this implies G into F, composition of two functions, that is GF, is also a 1, 1 mapping. That's a in correct. Okay, onto itself. Is it correct? If G and F and G are 1, 1, then G into F is also 1, 1. Look at here. Suppose this one is mapping F. Okay, what is domain? K and this one is K. 1, 2, 3. Three element I have. Okay, what is F? F is onto. That means K also have three elements. This maps to this. Second maps to second map. Third maps to this element. Okay, so this is K. F is what here? 1, 1 and onto. What is G? G is the mapping again from K to K na. This element maps to this element. इथे map असेल, इथे map असेल. This one is G. Okay, then you have G into F. Okay, कोणावर एलिमेंट होणार हा A वर. कसा अप्लाय होणार? G of F of A. F of A हा कुठे येईल? From इथे येईल या set. And G of F of A in this set. Okay, so this is what? F of G of हा मॅपिंग काय झाला? इथून इथपर्यंत म्हणजे हा G into F. Is it correct?
Yes, sir.
Hence, G into F, that is the composition of two functions. G into F is also what? 1, 1 mapping of K onto itself. Okay. Now, let A and B are the any two elements of K. Let A and B, okay, let A and B be any two elements of capital K. Then we have, what we have? We have G into F into on A into B is equal to, कसा आपला होणार? G into F of AB. But F is what? Atomorphism. So we can write this is F of A into F of B. What is the reason? By the definition of F. Okay, that is F is 1, 1 and 2. So this implies. But here what? Into is there. Okay, now G is an atomorphism. So G is what? Satisfies G of F of A into G of F of B. Okay, so this implies G into F of A and G into F. Okay. Bracket G into F of B. So G into F of A into B is equal to what? G into F of A into G into F of B. Okay, and also G into F of A plus B is equal to G into, this one is F of A plus B. Okay, but what? F is an atomorphism. So G into this one is F of A plus F of B. So this implies now G is an atomorphism by the definition of G. This is one is G of F of A plus G of F of B. So this implies G into F of A plus G into F of P. Okay, is it correct? So this implies G into F also an atomorphism of K. This implies G into F is also an automorphism and automorphism of capital K. Thus, the set A of K. हा G into F कशात गेला? A of K. Okay, is closed with respect to composite composition. Composite composition. Any doubt?
No, sir.
जर एखादा फंक्शन ह्या
No, sir.
सेटमध्ये जायला एखादा फंक्शन ह्या सेटमध्ये जायला हवा तर तो काय असायला हवा एक तर 1 1 on 2 and also it satisfies the two properties. Which one? By the definition of homomorphism. These are the two ones. Okay, then that function belongs to set of all automorphisms. So here the G into F belongs to what? A of K. Now the second property, closure property. Okay, sorry, associative property. Second, associative. If the closure property is satisfied by that group, that set, then associative must be satisfied. Okay, so we know that here. Okay, here we know that the composite of arbitrary mapping of arbitrary mapping is associative. Associative. Okay, so this implies what? Composite of atomorphism is also associative. Okay, so composite of automorphism is also associative. Okay, there is no need to go again. G into F into H, okay, is equal to G into FH. Okay, any doubt up to here?
No, sir.
एखाद्या ठिकाणी जर क्लोजर प्रॉपर्टी सॅटिस्फाय झाली की असोसिएटिव्ह प्रॉपर्टी सॅटिस्फाय होते शक्यता. Okay, now the third one, existence of identity. Existence of identity. Okay. The identity function I. The identity function I on capital K is also an automorphism of K, capital K. Okay, then we know that the identity mapping is also 1 1 on 2. Okay, so obviously I is identity mapping is 1 1. Okay, 1 1 and on 2. Okay, now we have to do that. I of A into B is equal to I of A into I of B, and I of A plus B is equal to I of A plus I of B. Okay, if A and B are the two elements belongs to the set that field K, then I of A into B is equal to AB. Okay, by the definition of I. What is A? It is I of A. What is B? I of B. Okay, and I of A plus B is equal to, by the definition of A identity, this is A plus P. But what is A? I of A plus I of P. So thus I belongs to that set A of K. Okay. And if any mapping F belongs to set of all the atomorphism on K, then P I into F is equal to F, which is equal to F into I. Okay. Hence, we proved that here existence of identity in that set A of K, set of all atomorphism on K. Okay. Now, the next property is existence of inverse. Any doubt up to here?
No, sir.
Okay. सोपा आहे तेवढा काही हार्ड नाही आहे. Existence of inverse. Let this F, this mapping belongs to set of all the atomorphism of K. Since F belongs to that set, then F is what? 1, 1, onto and homomorphism. F is 1, 1 mapping of K. 1, 1 mapping of capital K onto itself. Okay. F is 1, 1 mapping of K onto itself. So this implies what? एखादा function 1, 1 आणि onto आहे. याचा अर्थ
F
काय?
inverse exists.
Inverse exist. का हो? असं का होईल? जर 1, 1 onto नसेल तर काय होईल? एकच मिनिट पाहूया. F inverse exists and it's also 1, 1 mapping of K onto itself. ओके. F इनवर्स पण काय येईल? 1, 1 असेल आणि तो काय होईल? K onto K itself असेल. Look at this one. Suppose this is the set K. 3 elements are there in K. Okay. And your codomain is also K. So this is 1, 1 mapping. Okay, this element maps to this one. This is 1, 1 and what? Onto also. So hence, if this one is F, so we can define from the codomain to domain F inverse. Okay, so F inverse is also what? 1, 1 and onto. But suppose this is our K and this is also codomain K. 1, 2, 3. 1, 2, 3. Okay, now suppose this element maps to this one and this element maps also this one. This is the function. Okay, every element of the domain, there is an image in codomain. Okay, unique image. याला पण unique image आहे आणि याला पण unique image. But this is what? Not 1, 1.
Onto.
Not 1, 1 and onto also. हा इथे आहे समजा किंवा okay. And not 1, 1 onto also. Okay. Now, can you define the F inverse from the codomain to domain?
No, sir.
जर डिफाईन जरी करण्याचा प्रयत्न केला तर काय होईल? आता हा के इकडे आलाय तुमचा. ओके. दिस वन इज कोडोमेन. नाउ दिस इज F inverse. Okay. 1, 2, 3. 3 elements. 1, 2, 3. आता हा फर्स्ट एलिमेंट कोणाला मॅप होईल? या दोन एलिमेंट्सला. ओके. This is the definition of. Is this the definition of function?
No, sir.
No. Because what is the what type of relation is?
One to many.
1 to many. So we cannot define F inverse if the function is not 1, 1 and onto. ओके. समजा फंक्शनचा डोमेन आणि कोडोमेन सेम आहे तर एखादा फंक्शन 1, 1 असेल तर तो ऑनटू असतोच. बघ, डोमेन आणि कोडोमेन जर सेम असेल तर तोच असेल. ओके. देयर इज नो नीड टू प्रूव्ह दॅट द ontoness if the domain and codomain must be same. If okay, if the function is 1, 1, then function is onto also. Okay, so here the F inverse exists and F inverse is also what? 1, 1 mapping from K and to itself. Okay, now to prove that the F inverse is also an automorphism of K. Okay, now we have to show that two condition hold by F inverse. Now to prove that F inverse is an automorphism, is an automorphism of K, capital K. Now let A and B are the two elements from the domain K. Okay, so this implies then there exists A dash and B dash belongs to K, such that F inverse. Okay, this A and B belongs to codomain. Suppose this one is codomain. Okay, so F inverse of A is equal to A dash and F inverse of B is equal to B dash. This implies and implied. If F inverse of A is equal to A dash, then what is F of A dash is equal to A.
A.
Okay, so this implies and implied F of B dash is equal to B. Okay, आशा से. What's this? K. This is the mapping from F inverse from K to K. Okay, the A आणि इथे काय तुमचा B. So A dash is this one, and this one is B dash. Okay, so A and B, F inverse is, let A and B are the two elements from the K, then there exist A dash and B dash such that F inverse exists होतं म्हणून सांगितलं आहे. So F inverse of A is equal to A dash, which implies and implied F of A dash is equal to A. F inverse of B is equal to what? B dash. This implies and implied B dash is equal to B. Okay, now we have, now we have, what we have? F inverse of A into B. Wait a minute. F inverse of A into B. So this is equal to, what is A? This is F inverse as it is. What is A? Get here. F of A dash. Okay. This is F of A dash. What is B? F of A dash. Okay. Now F inverse, and this one is F inverse. But what is F? F is an isomorphism. So this one is F of A dash into B dash. So F inverse into F is what? Identity. Okay, we proved the existence of identity in the previous case. Third number. This one is fourth now. Wait a minute. Existence of identity, existence of inverse. This one is fourth. Okay, in the, from the third case, we proved that F is there exists an identity. So F inverse into F is I. So I of A dash B dash is A dash into B dash. Okay, but what is A dash? F inverse of A. And what is B dash? F inverse of B. Is F inverse of A into F inverse of B. Okay, any doubt?
No, no, sir.
No, sir.
Okay, so here F inverse of A into B is equal to F inverse of A into F inverse of B. Now also F inverse of A plus B is equal to, this is F inverse. Okay, what is A? F of A dash plus what is B? F of B dash. Look at it. A and B. F of A dash and F of B dash. Okay. Now apply the F inverse on the both. Sorry. F inverse into, but F is what? Isomorphism. That is automorphism on K. So this is F of A dash plus B dash. So F inverse F is equal to I, where I of A dash plus B dash is A dash plus B dash. But what is F A dash? F inverse of A plus what is B dash? F inverse of B. Get it? A dash and B dash is equal to F inverse of A and F inverse of B. Hence, F inverse of A plus B is equal to F inverse of A plus F inverse of B. So this implies F inverse is an automorphism. Automorphism of K. Thus, if F belongs to set of all the atomorphism of K, this implies F inverse also belongs to atomorphism of K. So therefore, hmm, each element, each element of A of K possess inverse. Okay, any doubt up to here?
No, sir.
No, sir.
Hence, the set of all atomorphism of K, that is A of K, is a group with respect to composite composition. Okay, okay. Any doubt up to here?
No, sir.
No, sir.
Wait a minute. Now, the next definition is fixed field. कोणकोणते fields झाले? Separable field. Okay, separable extension होता है. Perfect field. Every extension is separable extension. Now, the definition of fixed field. What is the fixed field? The next definition is fixed field. Look at here. Fixed field. Okay. Let. नीट लक्ष द्या. थोडं किचकट आहे. किचकट म्हणण्यापेक्षा लक्ष दिलं तर समजेल व्यवस्थित. Let G be a subgroup. Okay, or simply a group. Subgroup हा group असतोच. Or simply we can say that a subset. In the bracket. Let G be a subgroup or of group of all automorphisms. Group of all automorphisms. Okay, of a field K. Of a field K. What is G? G with the subgroup of group of all atomorphisms of a field K. Then the fixed field. Then the fixed field of G. What is the fixed field? The fixed field of G is the set of all elements. Set of all elements A belongs to capital K such that sigma of A is equal to A for all sigma belongs to G. Okay. What is this fixed field? Look at it. Let G be a subgroup of group of all the atomorphism of a field K. Then the fixed field of G is the set of all the elements A belongs to K. म्हणजे तुमचा फिक्स्ड फील्ड कोणाचा कुठून येते ह्याच्यातले एलिमेंट कुठून येते तुमच्या मेन फील्ड मध्ये. ओके, हा itself a as k असेल किंवा subfield of k असेल. Okay, this fixed field of G is the either subfield of k or itself a k. Look at it. Now, what is A of k? Set of all automorphism of capital K. Okay, what is the fixed field of G? What is the fixed field of G? G काय तुमचा? Be a group of atomorphism. G be the subfield. Sorry, subgroup. हा G काय तुमचा? Subgroup आहे. Suppose there are four elements in A of K. Which one? Sigma 1, sigma 2, sigma 3, sigma 4. Okay, these are the four functions, that is four atomorphism on the set of on the field of this field K. Okay, what is G? G be the, look at here, subgroup of a group of atomorphism. हा set group होते आत्ताच आपण प्रूव्ह केलं. Let G be the subgroup. Subgroup हा itself हा A of K असेल किंवा काय असेल, सबसेट तरी असेल त्याचा. ओके, सो G इज इक्वल टू वॉट, यातले काही एलिमेंट्स येतील सिग्मा 1 सिग्मा 2. ओके, और काही काही येऊ शकेल, वेट अ मिनिट, और दिस सेट मे बी द सिग्मा 1 सिग्मा 2 सिग्मा 3 सिग्मा 4. ओके, काही येऊ शकेल, पण ह्याच्यातले एलिमेंट येणार या G मध्ये. ओके, तो काय असेल, सबग्रुप असेल. सो लेट G बी अ सबग्रुप ऑफ group of atomorphism of a field K, then fix the field of G. Suppose these are the two elements in G, okay, which is the subset of what? Or subgroup of A of K. Okay, wait a minute. What is G? Suppose G, in G there are two elements, sigma 1 and sigma 2. What is the fixed field of G? हा तुमचा K, the field. Okay. What is the sigma fixed field of G? Fixed field of G. Suppose this fixed field is F. F हा असा collection आहे. Take the elements from the K such that sigma of A is equal to A for all sigma belongs to G. ओके, कळते का काय सांगतोय? म्हणजे या के मधल्या कोणकोणत्या एलिमेंटला, जेव्हा आपण ह्या के मधल्या एलिमेंटला जेव्हा आपण सिग्मा 1 सिग्मा 2 अप्लाय करू, तेव्हा काय येईल, तो सिग्मा 1 ऑफ ए इज ए, सिग्मा 2 ऑफ ए इज इक्वल टू ए फॉर ऑल म्हटले ना, फॉर ऑल सिग्मा बिलॉंग टू जी वी गेट सिग्मा 1 ऑफ ए इज इक्वल टू ए, सिग्मा 2 ऑफ इक्वल टू ए. ओके, so this is the fixed field of G. Fixed field of G is nothing but the collection of the elements from the field K such that sigma of A is equal to A for all sigma belongs to G. Okay. Annihilator वाचता का? Annihilator कधी पाहिलं का? Annihilator, what is annihilator of a set? Linear algebra. Okay, just third sem lesson. This is definition. So what is the fixed field of G? The collection of all the elements from the field K such that sigma of A is equal to A for all sigma belongs to G. Any doubt?
No, sir.
No, sir.
A of K with the set of all atomorphism and G with the subgroup of that A of K. Okay, suppose हा G काय असेल, त्याचा सबसेटही असेल किंवा itself तो हा itself G हे असू शकेल बघा. Every group is a subgroup of itself. Okay, I don't know what is G. If suppose G is sigma 1 and sigma 2, then fix the field of G is equal to the collection of all the elements from the set K. कोण K? हा ह्याच्यातला K, हा जो काही फील्ड असेल त्याच्यातने असे एलिमेंट्स बाहेर काढायचे की तो फिक्स्ड असेल. फिक्स्ड पॉइंट हे वाचले का? व्हॉट इज फिक्स्ड पॉइंट? F is the mapping from, suppose, a set A to A. What is fixed point? F of x is equal to x. Then x is called what?
Fixed point.
Fixed point. Hmm. Identity mapping आहे. Identity mapping. F of x equal to x. Okay, x is called a fixed point. नंतर नको आहे. रिअल मध्ये आहे ते. y is equal to mx ला infinite fixed point.
झालंय सर हे.
झाले ना?
येस.
Okay, what is fixed
येस
point?
सर, कॉम्प्लेक्स अनालिसिस मध्ये.
कॉम्प्लेक्स पॉईंट अनालिसिस त्या म्हणाला फिक्स पॉईंट याचाच अर्थ इथं काय ह्याचाच फिक्स फील्ड आहे फिक्स फील्ड म्हणजेच काय एव्हरी एलिमेंट फ्रॉम दिस सेट ए ओके टेक द कलेक्शन फ्रॉम द एलिमेंट्स फ्रॉम दिस सेट फील्ड के such that sigma of a is equal to a okay and this fixed field of g this f must be in subfield ह्याचा सबफिल्डच असतो ओके हा काय फॉर्म करतोय असे कलेक्शन मी डिफाईन केले किंवा असे कलेक्शन मी वेगळे केले ह्याच्यातून या सेटमधून आणि त्याचा कलेक्शन घेतल्यानंतर तो कोणाचा सब फील्ड येतोय या केचा सब फील्ड येतोय एफ इज द सब फील्ड ऑफ के ओके सो दिस इज द फिक्स्ड फील्ड ऑफ जी ओके समजा यात एकच एलिमेंट आहे मग इथे ही कंडिशन गायब होईल मग ह्याच्यात एलिमेंट काय असतील वाढण्याच्या शक्यता असेल ना अजून काही इज इट करेक्ट
येस सर.
ओके ह्याच्यात एलिमेंट अजून इन्क्रीज होऊ शकतात वाढू शकतात पण ह्याच्यापेक्षा कमी नाही होणार बिकॉज हे फॉर ऑल जी बिलॉंग्स टू जी म्हणजे हा तुमचा फिक्स्ड फील्ड कोणावर डिपेंड आहे या जीवर इज इट करेक्ट म्हणून त्याला फिक्स्ड फील्ड ऑफ जी असं म्हटलं ओके सो फिक्स्ड दिस इज द डेफिनेशन ऑफ फिक्स्ड फील्ड ओके now look at it for example if you take the example then the idea is clear now. Suppose k is q root 2 okay what is the nature of q root 2 a plus
A plus b root 2.
a
AB belongs to Q.
a and b belongs to q okay then how many atomorphisms we can define on this set sigma of a plus b root 2 is equal to this suppose this one is sigma of a plus identity mapping 1 and sigma 2 of a plus b root 2 is equal to a minus b root 2 then what is a of k that is a of q root 2 is what set of all atomorphism is
Sigma 1,
sigma
sigma
1
2.
sigma 2 okay if you take this is G, that is the group of all atomorphism. And what is the fixed field of G? Fixed field
Sigma 1.
of G is equal to that is this G is equal to sigma 1 आणि sigma 2 दोन्ही आहेत तुमचे ओके फिक्स्ड फील्ड ऑफ G असे कलेक्शन घ्यायचे कोणातून कुठले एलिमेंट्स घ्यायचे this is the set A belongs to Q root 2 such that sigma 1 I of A plus B root 2 is equal to A plus B root 2 okay for all sigma I belongs to what G na now look at it जो कोणी फिक्स्ड पॉइंट फील्ड येईल तो कोणाचा सबफील्ड असेल ह्याच्यातले कलेक्शन असतील ओके सपोज दिस वन इज क्यू दिस वन इज क्यू रूट ओके इफ नाउ फिक्स्ड फील्ड ऑफ जी फिक्स्ड फील्ड ऑफ जी is equal to q is it correct what is fixed field of G? G is what? Sigma 1 and sigma 2. ह्याच्यातले कोणते असे एलिमेंट आहेत जे सिग्मा 1 ऑफ A is equal to A and sigma 2 of A is equal to A. What is sigma 1 and sigma 2? Sigma 1 of A is equal to A असायला हवा and sigma 2 of A is also equal to A. Now take the element from the field, this field Q. We get what? Hmm. If A belongs to Q, then sigma 1 of A. Hmm. हा नेचर कसा असेल तुमचा A प्लस बी पार्ट तुमचा 0 असेल ना. ओके बी नसेलच की तसा.
Yes, sir.
सो इथं काय ना 0 जर A जर Q मध्ये असेल तर by the definition of sigma 1 this one is A plus 0 root 2 that is A. Okay, wait a minute, this one is A. Now sigma 2 of A plus 0 root 2 by the definition A minus 0 root 2 that is equal to A. So here sigma 1 of A is equal to A, sigma 2 of A is equal to A if A belongs to Q. ओके दोन्ही मॅपिंग साठी तुमचा काय व्हायला पाहिजे हा फिक्स्ड पॉइंट हियर ठेवायला. सो व्हॉट इज द फिक्स्ड फील्ड ऑफ जी हियर? Q. Is it correct?
Yes,
समजते
sir.
का? नाउ चेंज आता ह्याच्यात सिग्मा 1 आणि सिग्मा 2. ओके नाउ टेक G is equal to sigma 1. Let G is equal to only sigma 1 which is the identity mapping. Okay, sigma 1 तुमचा काय आयडेंटिटी मॅपिंग आहे ना. This one is the
Yes, sir.
identity mapping. Then असे कोणते एलिमेंट आहेत? What are the elements from this field Q root 2? Okay, such that sigma 1 of A is equal to A. Sigma 1 of A plus B root 2 by the definition of sigma 1 A plus B root 2. So take any element of Q root 2. We get each and every point is fixed for all the elements of G. All the elements म्हणजे इथे किती आहेत एकच आहे ना. So A plus B sigma 1 of A plus B root 2 is equal to A plus B root 2 for all x किंवा all A plus B root 2 belongs to Q root 2. So what is the fixed field of G here? Fixed field of G that is equal to sigma 1 Q root 2. Is it correct? Is it correct? Sigma 1
फिक्स्ड फील्ड सर क्यों येतं ना फक्त मग?
हे सांगते मी तुम्हाला. जर तुमचा जी जर चेंज झाला तर पूर्ण तुमचा सेट चेंज फील्ड चेंज होतोय. समजा तुमचा इथे जी काय होता आधी सिग्मा 1 आणि सिग्मा 2. इज इट करेक्ट? वेट अ मिनिट.